first question we always ask is, can we take out a GCF? We also notice a negative out front. We see a lot of evenness. 4 goes into all three terms. So I'm going to factor out a negative 4 as well as an x. Dividing that out leaves me with 2x squared minus, watch the signs, minus 4x followed by minus 5. And a little bit later we might learn that we can break this down further, but I don't see that this is going to factor any further. So that one, all we could do was take out a GCF. The second one is ready for us to look at as a partially factored already. Partway through the grouping method, we see an x plus 7 common to both halves of the problem. Dividing it out leaves us 5x squared from the first half of the problem and minus 8 from the second half. And that doesn't factor any further. Number 13 has 4 terms in it. But before we move on to the grouping method, we look for a GCF but don't find one. So I'm going to split that baby down the middle. A goes into the first 2 terms, so dividing it out, C goes into the first 2 terms, so dividing it out we have 2 plus A. And then I see a 3y going into the second 2 terms, and that leaves us with a plus 2. The 2 plus a and the a plus 2 are the same by the commutative property of multiplication. I'm going to choose to write that as a plus 2. Dividing it out of each half of the problem leaves c from the first half of the problem and 3y from the second half of the problem. Okay, number 14. Nice good review here. Hopefully it's helping you. We see 4 terms. 4 terms usually leads us to the grouping method. I don't see a common term that can be factored out, so I'm going to move on to splitting the problem in half. In the first 2 terms I can divide out an x, leaving y minus z. And in the second half of the problem I can divide out a 7, leaving y minus z. Dividing the y minus z's out of each half of the problem gives us y minus z out front times x plus 7. And let me remind you, I don't have to write this in this order. It's perfectly fine to write the x plus 7 first, then times the x minus z, or y minus z, because the commutative property of multiplication says a times b is the same as b times a. Okay, the final problem of this little mini review. We see a lot of terms, we see a lot of 4's and 3's and x's and y's. So we begin by asking whether there's anything that goes into all the terms. No for the 4 versus 3, x's, 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 no x's, y's, 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 no y's. So there is no GCF. We're going to go straight to splitting it down the middle. From the first 2 terms I can divide out an x squared, leaving me 4x plus 3y. And in the second half of the problem I see a y squared common to each term, so dividing out the y squared leaves me 4x plus 3y again. And there's that common 4x plus 3y, which gives us 4x plus 3y times x squared plus y squared.